So in this video, we're going to look at simplifying simple products and quotients that involve the complex unit or complex numbers. So here we'll start with something very simple. We have the square root of negative 75 and we are asked to simplify this. So I'm going to start with the square root of negative 75. And we're going to do this a couple ways. So one, I'm going to show a lot of detail, and the other will show a little less detail. So one way to think about this is that we can break negative 75 into 75 times negative 1. And then we can break apart the square root of the 75 times the square root of negative 1. And 75, I want to recognize that 75 can be broken into 25 times 3 is still 75. So I'm looking for something that's got a perfect square. So I can put the square root of 75 into simplified radical form. We know that we've given the square root of negative 1 the name I. So I'm going to come here where I have the square root of negative 1 and just replace that with I. And notice the I is outside that radical sign. The square root of negative 1 is I. There shouldn't be a radical sign around this I anymore at this step. And then I recognize that the square root of 25 is 5. The square root of 3 is just the square root of 3. There isn't a nice whole number such that when I square it I get 3. And there's my I. So this would be in simplified radical form. We could show a little less detail than that. We could recognize the fact that if A is a positive real number, that anytime we have the square root of the opposite of A, we're just going to get the square root of A times I, where I is not underneath the radical sign. So I could start with something like the square root of negative 75. And I could, so notice here my style was to go equals, and so I made an identity and then I pulled it down the page using vertically aligned equal signs. So another way of simplifying this would be to not introduce an equal sign and just pull my work vertically down the page. So I could recognize that I'm going to get 75I from here. I could just automatically go to the I instead of going through this intermediate step that I did here, recognizing that that's going to happen every time. And then I would want to recognize that 75 can be broken into 25 times 3I, and the square root of 25 is 5, and the square root of 3 doesn't come out as a nice whole number with my I. So here's one where I have a quotient, and we'll play this one out a couple different ways. So we could start by saying, hey, I have negative 12 over 25. There's the number I'm starting with. And then I could recognize that this is the same as 12 25ths times negative 1, all under the radical sign. So I notice that I can break them apart into 12 25ths times the square root of negative 1. And then I want to start breaking these apart, so I want to look for perfect squares in here. So it's going to be 4 times 3 is 12, and 4 is a perfect square. And 25 is already a perfect square. The square root of negative 1 is just I. And then I could say, hey, I've got a fraction. I know how to simplify the square root of 4. That's just 2. And the square root of 25 is just 5. But the square root of 3, I don't know it. It's just the square. It is just the square root of 3 and times I. And this is simplified. Common student error in homework is to take this I and start to push him down so that he looks like he's in the denominator. He isn't. He is a numerator position. You should have him lined up exactly on the halfway mark with that fraction bar. The other thing that we could have done here, so we could have done this a little bit differently. Let's do this a slightly different way than we did it here. Should still get the same thing. So let's say I start with negative 12 over 25. We could do the same thing that we did in the previous slide, where we recognize that if we have the opposite or negation of A in here, that this is going to turn into the square root of A times I. So I could have taken this and just directly written it as square root of 12 over 25 I, pull that square root of -1 out into the I position right away, skipping this intermediate step. You still need to try to break the numerator and denominator into perfect squares to get it into simplified radical form. And then we could recognize that if we have a ratio of two positive numbers under the square root sign, that this can be broken into the individual square roots, so square root of the numerator over square root of the denominator. So I could have at this step rewritten it as root 4 times 3 over root 25 with the I halfway, centered halfway on that radical bar. And then we simplify. Square root of 4 is 2. Square root of 3 doesn't simplify. Square root of 25 is in the denominator position, so we just get 5, and this is times I. So here's one where we have a product of two pieces. So square root of 35 times the square root of -15. Want to recognize right away that the square root, there's a square root of -1 in here, so we could just go directly to saying, hey, I have the square root of 35 times the square root of 15 times my I, break that I out. Recognize that this product of two square roots with positive numbers under the radicals can be written with the pieces together underneath a single radical sign times I, which isn't under a radical sign. And what we want to do is kind of break these numbers apart. So 35 is the same as 7 times 5, and 15 is the same as 5 times 3. So what we see is we're getting a 5 times 5 sitting under there, or 5 squared. We're going to be able to simplify that, whereas the square root of 7 isn't going to simplify, and the square root of 3 isn't going to simplify. So I'm going to get 7 times 3 is a 21. But the square root of 5 times 5, we want to recognize that 5 times 5 is just 25. And if we have the square root of 25, that's just going to give us a 5. So the square root of 5 times 5 is going to be 5. That 5 is going to be out of the radical sign now because I just took the square root of 25 and times I. And that would be in simplified radical form here. We've got a ratio. And what I want to recognize is that I could rewrite this as the square root of 33I with the I out of the radical sign. And we could rewrite this as the square root of 3I. And I divided by I is going to equal 1. So that will simplify. And I have the square root divided by a square root. I can bring them together if I want to, which is going to give me just the square root of 11, and 11 is a prime number, so it's not going to have a perfect square embedded into it, so it's in simplified radical form the way that it sits. So last example here, we've got an 8 plus the square root of -32 all over 2. We want to recognize that we can break this into two fractions. And I should mention, it says standard form. Anytime you see standard form, it's saying to write it in the form A plus B times I. So we should have a real number part, and then we should have a real number times a complex, times the complex number. So we want it in this form. Standard form means write it so it looks like A plus BI. So we've broken this initial ratio into two pieces. This is going to simplify to a 4. That's going to be equivalent to your A. And then we want to recognize that the -32 up here can be rewritten as 32I. And it's over the 2. And we want to recognize that the square root of 32 can be rewritten as 16 times 2 is 32. There's my I, and this is over 2. So this is going to equal 4 plus the square root of 16, I know it. It's 4, and the square root of 2 isn't going to simplify, and it's still over 2 times the I. So I get 4 plus 2 goes into 4 twice, 2 times the square root of 2 times I, and now I have a complex number in standard form. Here's the real part, and here's the complex part. I have a real number coefficient times I.